open the try to search in the Windows like Anaconda prompt. If you already have installed in your system Anaconda prompt, try search in the Windows as Anaconda prompt. Just it will open like as a command prompt black screen. How it get open? The similar way Anaconda prompt also it looks like that. Please open that. So So after opening this Anaconda prompt, just keep somewhere wherever you want to store all the different Python files in one folder. Suppose if you have D drive or E drive or F drive in your system, please store every file. What are the Python files we are doing everywhere in the class? Please store all the files in that folder only. So whenever you created some Python folder in D drive, just to try to change to D drive. So, so that is I have stored, this is a D drive. I have created a Python folder. Whatever the files which I am discussing related to Python class, everything I have kept it here. The similar way here also, you also in your system, try to create some folder in your system, and after creating a folder, just try to open an Anaconda prompt and change to that particular directory. Directory is nothing but a folder. So where I am trying to go to the Python. After going to the Python folder, just to try to open the Jupyter notebook. CD space D colon backslash the Python folder. After going to change to that particular D drive and try to type Jupyter space notebook. So Jupyter notebook it will get open. So it will open the Jupyter notebook. So after opening this, here you open the new Python 3. So notebook. So notebook will open. So please follow up to here. Make sure that everyone open the Jupyter notebook.
Ravi, Haris is newcomer, okay? He joined today.
Pardon?
Haris.
Haris, okay.
He is a
Fine.
newcomer, he joined today, so he's my friend.
Okay.
So he's gonna put up this class, from today.
Yeah, that is fine. But he also supposed to do the same thing.
Yeah, I do have these things installed already in my machine.
Yeah, whoever not done. For Haris, it's new now. So for him, he can follow that and he can open the Jupyter notebook. So Haris, please confirm whether you open.
Yeah, I'm just booting up my laptop. Yeah, so I'll just do it. Yeah.
Yeah, please follow along with me so that it will be easy for you if you don't if you are new to Python. So whatever we are seeing here, this is called as a cell. So whenever you click on here, it will turns to a blue color. After turning to a blue color, if you press A button in your keyboard, it will come above the cell. Again, if you try to select this and if it turns to blue color, if you press B in your keyboard, it comes to the below of the cell. So that is above or below of the cell. So here, if you want to write something program like 2 plus 3, it will return the result as 5. So whenever you run, you will be getting the same result. Even if you press shift plus enter also, you will get the same result. Shift plus enter is a keyboard to execute the particular cell. Or if you press the run the cell, then also you will be getting the output. So prefer try to use the shortcut instead of doing the this manual, that is run button. Instead of UI symbol run, you can use the shift plus enter. By using shift plus enter through keyboard shortcut, it will execute the cell and it will throw a result. So already we have discussed some, I assume that we have discussed some of the arithmetic operations. So today we will discuss some of the operators like arithmetic operators, comparison operators. So first we'll discuss the data types. Next we'll go all these things. So first of all, if you are going to see the integer data type, whether I have told what is meant by, I think variable I have discussed in the last class itself. What is meant by variable? How we have defined the variable. If you are going to store some of the data inside the variable, and if you want to check the what is its data type, in the other programming languages, if you want to give some data to the variable, first you have to initialize that variable. Whether that variable is an integer, whether that variable is float, whether that variable is string, or you have to initialize it first. Then only you can declare. But here you no need to declare anything. Python itself can understand that what the data you have given to that variable automatically, and it can understand its data type. If you are checking type of A, here you know here anywhere you not define anything as like integer A. So generally in C language you used to give like this. Int A comma B comma C, like this you used to give. That means for all the variables you are trying to initialize. In other programming languages you are defining the data type. Unless if you are not defining the data type, it cannot understand in other programming languages. But in Python, there is a flexibility. In Python, there is a flexibility where you no need to define any data type. Whatever the data you assign to the variable, it can understand by itself. Suppose if you are going to check type of A, it will throw as an integer. If you are giving the floating point data type 34.57, it will understand that it is a floating point data type. So if you are going to check type of A, it will throw again the result as floating point. So like that, if you are giving b equal to something like boolean value we can give either true or false. If you are going to check the data type, it throws as a boolean. Again, we have the another data type, that is a complex data type in Python, like 78 plus 8j. If you are checking that type of C, it throws as a complex number. It throws as complex number. So like that, we have the integer, float, boolean, as well as complex. Next one is a string. D equal to Python. If you are going to give, and if you are going to check what is its data type, again it will throws as a str. So we have different data types. All the five different data types we have discussed now: integer, string, boolean, complex, and the floating point. These data types all we'll call it as a primitive data types. You no need to declare anything initially. If you, after defining it, assigning the data to it, and if you check its data type, it can give. So related to data types, primitive data types we have discussed now. Next one is we'll discuss now some of the arithmetic operators. So if you want to keep a heading, so in the notebook, how you will write the notebook, like if you are taking a notes or white page notebook or anything rule notebook, simply you will keep a heading and you will write the notes. So the similar way, even Python notebook also you can follow the same structure. whatever you want, you are writing here, everything comes under one section, and you can keep a heading at the top of this thing. Next, suppose for the cell, if you choose as markdown and if you press hash symbol, and you can keep the heading like this, operators. I am going to discuss now operators. Whenever you are going to discuss now operators, just you can select as markdown here. Again, if you press double hash symbol, whenever single hash symbol, the size of the letters get increased. When you press double hash symbol and you press give the space after the double hash and you give as operators, the size of that will get reduced. So whenever the hash symbol get increased, the size of the letters will get decreased. So for the heading, so that is your wish. You want to give either main heading or subheading, how you want to make the notes, that is your wish. So like that you can keep the mark down and you can keep a heading. After keeping a heading and you can keep it down. Whatever we are discussing, everything you can do it under the heading. So in that operators we will discuss now is addition operator, subtraction, all these things. Suppose if I am giving us a equal to 3, b equal to 2, if you want to do an addition, this is an arithmetic operators. All we are discussing now as an arithmetic operators. If you are trying to do an addition a plus b, it will written as 5. The similar way, if you are trying to do a subtraction a minus b, it will written as 1. So arithmetic operations is simply like addition, subtraction, multiplication, division. All this comes under the arithmetic operations. Suppose A into B. If you can do multiplication operation, you will get result as 6, A by B. If you are resulting, you will get as 1.5. The same thing if you are doing A modulus B, you will get result as 1. A modulus B is nothing but the whenever if you divide the with some number, then whatever the remainder you are getting, that itself is called as a modulus operator. So modulus operator always it will throws a remainder. Next one is if you want to, if you are doing as A by B, you are getting as 1.5. That is fine. The same thing if you are doing as a floor division, A double slash b, that means decimal point will not be getting. So whatever before the decimal point, whatever the number it is there, that is as a quotient, only that it will get as 1. Whatever after decimal point it will get removed, that is called as a floating point. Floating point gets removed whenever you do the floor division. Floor division always which returns a quotient, but it will not returns as a floating point. It will returns always an integer only. So this is a three kind of division: A by B, A modulus B, A floor division B. Floor division B always returns an integer. The decimal point, floating point will not be allowed. Only whatever if you do a division with some number, whatever the resultant you are getting, that only it will get displayed. Is it clear up to here related to arithmetic operations? Please respond. Is it clear or not?
Yes, sir.
Yeah, it's clear.
Okay, next we are going to discuss now comparison operators. So whatever the number we have stored in one variable, in another number also we have stored it in another variable. Just we are trying to do now comparison operations. So those are called as comparison operators. Whenever if you are doing a comparison operators between these two, that is a equal to 2, b equal to 3. If you want to do a compare between the two numbers, whether both are same or not, just you can do as a equal to b. So whether a and b both are equal, no, it is not equal. So a variable storing the data as 2, b variable the data it is storing as 3. 2 and 3 is not equal. So if both the data is not same, then it returns as false. Suppose the same thing if I am giving as a not equal to b, it returns as true because a and b both are not true. So a storing as 2, b storing as 3, these two data is not equal. So that's why it written as true. The similarly, a is greater than b. So whether in the a it is storing as 2, b is 3, whether 2 is greater than 3, no, so it returns as false. The similarly, if you are doing a less than b, it returns as true. So you are doing a comparison operators between the two variables, whether those are equal, whether those are not equal, whether it is greater than, whether it is greater than or equal to, or less than or equal to. So all these operations comes under the comparison operators. Just you are trying to compare some data. Suppose if you want to perform some logic, if you want to perform some logic, so if you are doing comparison operations, if you are doing some kind of a comparison operators between those two variables, whenever if it is true, then it returns as true, otherwise it returns as a false. That what we have discussed here. Next one is logical operators. Logical operators, in the logical operators, just you are trying to do the logical operators is nothing but the you are trying to you get as like a and b, a or b, whatever it may be, you are trying to do as just you are doing perform kind of a bitwise operations. We will discuss those now. So up to here, if you have any doubts, you can ask me. So I think everyone knows that AND operation or operation, not operation. Already we have you have come across all these things from your childhood onwards, like AND operation or operation. So we will discuss those now. Suppose if I am going to do a logical operators where we have seen as like an or operator, not operator, all these things comes under the logical operators. So those we will discuss now. And operator or operator are not operators. So in this So suppose if I am giving as A equal to 3, B equal to 2, C equal to 1. So I am telling that if A is greater than B and B is greater than C. So I am going to compare the two comparison operators I am giving, but I am doing the AND operation. If these two conditions are satisfied, then what something you have to do. That is what you will be implementing in the programming. Here A is greater than B. Yes, it is satisfied. Even B also it is greater than C. It is satisfied. Both the comparison operators condition is satisfied. If these two conditions are satisfied, something it has to do that you will be writing inside this condition. So when both is true, it returns as true only. The same way if you are returning as A less than B and B less than C. If I am trying to write like this, it returns as false because whatever the A is 3. So 3 is less than 2, false. Even B is less than C, false. It returns as false. I think if the both the numbers are same, that is true into true, and the operation internally works like as a multiplication. So like that, this is A greater than B, that means it is true. B greater than C, it is true. True into true, that is 1 into 1, you will get as 1. So that in the Boolean it represented as true. But here A less than B, it is a false. B less than C, it is also a false. False is nothing but 0. Here also 0. 0 and 0 internally, 0 into 0 is 0. That means you will be getting the Boolean as false. So next one is the similarly A less than B. Suppose A less than B, if you are taking as, you do the multiple combinations. I have taken only two conditions. No, here this condition is true. Again, you give as false condition. Again, you give false condition. Again, you give true condition. You do another two combinations also. A less than B or B greater than C. If I am giving like this, at least if one condition is satisfied, it returns as true. But in the AND operation, if both the conditions, if it is satisfied only, then only it returns true. Our operation, it will do as internally a kind of an addition operation. If 1 plus 0 is returns as 1 only. 1 means internally indicates as true. So that is A less than B, the condition is satisfied. No, it is false. B greater than C, as the condition is satisfied. 0 plus 1 is 1. That means 1 internally indicates as true. The similarly you do for the not operation also. Suppose not of, you are doing the comparison whether A equal to 3. So whether the data 3 is equal to or not, you are checking the condition. A equal to 3, it returns as false because A equal to 3 is true. So whenever you perform the not operation on this, it returns as false. The similarly, whenever if you are trying A not equal to B not equal to 2. If I am trying to give it returns as true. So B not equal to 2, B actually it is equal to 2. But I am trying to do a comparison that B not equal to 2. So that means it returns as false. So while you apply not operation on this, it returns as true. So this is a kind of the AND operation, OR operation and NOT operation. So, so up to here, if you have any doubt, you can ask me. Next one is we are going to discuss now as bitwise operators. In the bitwise operators, so whatever we have discussed till now is A and D, OR and NOT. The similarly here also will be using same kind of operations, that is with the ampersand or symbol like that. So if you want to represent the AND gate, suppose A equal to 4, B equal to 2, if I am giving, if you want to do an ampersand between these two, that is A ampersand 4. If you are A ampersand B, if you are trying to give A ampersand B, so we'll convert this. I will show now how it will result and how you will be getting. So here AND operation, OR operation, NOT operation, whatever you are doing here in the logical operators, just it will return either true or false. That's what we have seen. But here, whenever you are doing bitwise operators, you will not get in the form of true or false. You will be getting some kind of a resultant. Suppose A equal to 4, B equal to 2 if you are doing, so you are trying to convert this into a binary language. For how it will be, you will be represented in the 100. So whenever b equal to 2, if you are going to represent the binary language of 2, it represented as 010. So do the multiplication operation, that is A ampersand B. Whenever you are doing ampersand B, just you multiply 0 into 0, you will get 0. 0 into 1, you will get as 0. 1 into 0, you will get as 0. 0 into 0 as 0. Overall, it represented as 0. The same thing if you prove here, it has to get the 0 only. Yes, you are getting the 0. So here I have written the binary language. I think most of the people know. I think you people know or not, I don't know how to convert from decimal to binary. I think you come across in your education how to convert from decimal to binary language. If you don't know also, no issue. You can take the help of the Python. If you choose binary of A, it is converted that into a binary language. Even binary of B, if you are trying to ask it, it will give us in the binary language. Just you do a multiplication operation between these two bits variables and the resultant will be getting displayed as totally as 0. Next one is ARB. If you want to do an OR operation between these two, ARB means the same thing you do here. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. So whenever you try to convert this into a decimal representation, you will be getting as 6. That is, every bit indicates as 2 power 0. This indicates as 2 power 1. This position indicates as 2 square. How we will be reading a notation like the thousand units, tens, hundreds, thousands, 10,000, 1 lakh. How we will study in the Indian notation of representation of the digits. The similar way here also from the right to left, the representation starting from 2 power 0, 2 power 1, 2 square and 2 cube. So wherever the ones are there, you try to add those particular two numbers. That is 2 power 1 plus 2 square. How much you will be getting? 4 plus 2. That is 6. So this itself indicates as a representation as a 6. You are getting ARB as 6. If you are not getting, please let me know. I stop and you can ask in the middle. Next one is A XOR B. So XOR operation. If you want to represent this XOR operation, it will be represented with the some cap symbol. So whenever if you represented with the cap symbol A cap B, here you see now. So wherever A you are noting as 0100. So B as 0010. I think XOR operation you know. If the input digits are same, it represented as 0. If two different inputs are different, it will return as a 1. I think you come across this XOR operation in your childhood. So XOR operation always returns whenever the two inputs are same, it returns as a 0. Whenever two different inputs are there, it returns as a 1. So 0 into 0, 0, 0 into 1, 0, 1 into, sorry, 0 plus 1, 1, 1 plus 0, 1, 0. So we'll be getting as 0, 1, 1, 0. So whenever the two different inputs are there, it will returns as 1. Whenever the two inputs are same, it returns as a 0. So that what we have discussed here. A XOR B also, it returns as a 6. The similarly we have left shift operation and the right shift operation. Suppose A is less than 1. Whenever if you are doing less than 1, if you are trying to represent this in binary 100, so it will move to the left side to here A. Suppose if I'm going to represent it as A less than 1. So whenever if you are going to represent that less than 1, whatever the position is there here 1, it will move to the one position to the left side. That is 1 it will come here. So here the represented as 1 0 like this 4 representation. So whenever if you are doing left shift operation, this 1 will come to this position 1, this 0 will come to this position 0, this 0 will come to this position as 0, and wherever something position is there, that it will be occupied with 0. So you will be getting as 1 0 0 0. So whenever you are trying to getting as 1 0 0 0, if you are noting within, if you are trying to convert that into a decimal part, so now you convert to a decimal. This is 2 power 0 position. This is 2 power 1 position. This is 2 square position. This is 2 cube position. So wherever 1 is there, just you have to indicate only that. So 2 cube is nothing but 8. So that what it represented here. The similarly try to do the right shift operation. So whenever if you do a right shift operation, just whatever the number it is there here. So here we have done you have get as 100. So here it moves to the left side previously. So the same number, whatever the starting number is there, it will come and occupy this position. Okay. So you will be getting as 0 0 1. So whatever this position is there, it is going to get occupied into the here at the last position. Remaining all bits it will move towards to left side. What is there in the first bit, it will move towards to right side and it will get occupied here. So we will be getting as 0 0 1. So whenever it is occupied as 0 0 1, and you will be getting as 2. So remaining bits it should be occupied as 0 only. So that means you will be getting as here as 2 power 0 representation, 2 power 1, 2 square and 2 cube. So whatever the position actually it is there, it is going to occupy in that position. So remaining position will be there as it is like as a 0 only. So that is 2 power 1 is 2 only. So that's why you are getting a resultant as 2. Right shift operation whenever you are doing, if it is moving to the 1 bit, whatever the starting position, it will be occupied at the last position. So remaining bit will be replaced with the 0. So that's why if you indicate set, you will be getting a 0. So next one is negation A. Whenever if you are doing negation A, you will be getting as a 2's complement. 2's complement is whatever the number you are getting A value, try to convert this into a binary. After converting this binary, try to do a complement this number, that is 0, 1, 1. Again, you try to do with the plus 1, and you will be getting the final result as minus 5. Anyway, I am not explaining this. This is not that much important. So I have to tell everything. So which is necessary only I'm telling. Negation A is nothing but the 2's complement. So next one, next operators we are going to discuss now is final thing. So what we can discuss now, membership operators. So like membership operators generally, so these are called as, next thing is membership operators. Membership operators is, suppose if you are taking as a collection, in that collection there will be so many elements in that collection. This is a list. I am passing different data like 1, 2, 3, 4, 5, some Python, some Java, some different data I have given. I want to check whether the particular element is present in that list or not. You want to check. You have to check that condition. So you can write it as SQL, whether SQL is present in this list or not. If you are using in operator, this is called as a membership operators. Whenever you are trying to search something in this list, you are using in keyword, that is called as a membership. So it returns as a false. The same thing if you are checking condition is Python in L. So whether it is present true or false, you want to check. Yes, it is present. So that's why it returns as true. And if again SQL is not in, whether SQL is present, it is not present. So it is showing as SQL not in L. Whenever you are giving SQL not in L, it returns as true only because SQL is not present in that list. That's why it returns as true. So these are called as a membership operators. Is it clear up to here? Membership operators. So where you are telling in operator and not in. If you are using these two, those comes under the membership. Next one is, please respond. Please unmute your mic if I am asking, and please respond. So other yes or no, please tell. So next one is I want to discuss now is identity operators. In that identity operators, whether if you want to do similarly like a comparison operators, that is whether the both the lists are same or not. You are doing a comparison by using double equal to symbol. Whenever you are using double equal to symbol, just you are trying to compare between the two lists or two different data. Whether both the same or not, you are trying to compare. So here also, just we are doing a whether the data is the same or not. Data is same. So that's why even here we have the so here the whether the data is same or not, just you are trying to compare here. That is, if you are trying to, I will tell tomorrow this is a collections x equal to 1, 2, 3 and y equal to also 1, 2, 3. So this is a collection where I am going to store the data and I am going to see that whether the both the data is same or not. That is whether the x is y or not, you are going to check the condition. So x is y. So whenever if you are telling as x is y, I am taking the same data. So still it returns as false. But even though I am giving returns as same data. Why? Suppose the same thing if I am going to store in some other variable z equal to x, but whether I am storing x is z, so it returns as true. So that means directly if you are giving the same data and if you are trying to compare with the two variables, it will not return as true. But whatever the data you have stored in that variable and again you are trying to copy into the another variable, and if both the data are same or not, if you check that condition, then only it returns as true. So that's what I want to discuss here. Suppose x is y. X is y, yes, false. Why it is storing, whenever you are going to check, even though it is giving the same data, x equal to 1 to 3, y equal to 1 to 3, why it is storing, why is giving as false, because if you take a memory locations in your RAM, the x date, whatever the data, x equal to 1 to 3, this 1 to 3 will get stored where it will store in this memory location. For this memory location, it is pointed to x. Again, the same thing, I am taking the data as y equal to 1 to 3. And again, I am pointing to this data as here 1 to 3. But again, I am giving this memory location as y. Whether these two are same, two different memory locations, whether both are same, even though the data is same, but the storing at different locations. So that's why it returns as false previously. Whenever if you give like x is y, here it returns as false. But the same thing if you are storing the same data, storing the data in one memory location, again you are trying to copy the same data into another variable, and if you are trying to compare both the variables, it returns as true. That is what identity operators. Just you are trying to comparison whether both the same or not. Suppose the same thing x is not y. If you are trying to give yes, it returns as true. Both the both it will store in the different memory locations. Even though the data is same, but it's storing the data in the different locations. So if you are trying to compare, it returns as false only. Next one we are going to discuss now as unary operators. So in this unary operators, in the unary operators, that is nothing but the just you are doing a kind of an addition. So suppose just you are giving some kind of a sign to the particular variable, that is plus a minus a. Just you are assigning some kind of a sign operation to that particular variable, that is plus a minus a, like this. Suppose if I am going to give as a equal to 5, suppose if I am trying to call it as plus a, you are getting as 5. The similarly, if you are trying to give minus a, you will be getting as minus 5. So you are trying to just indicating as a signs to the particular thing. Suppose if you are trying to give negation of a, you will be getting as minus 6. Just whatever the thing it is there, you are trying to add with plus 1 and you will be getting as minus sign before that. So that is a negation operation. So next one is print of whatever if you are trying to give not A, you will be getting as false. Not A always indicates as a logical not. So A equal to 10 means actually it is true. But whenever if you are mentioning as not A, it returns as false.
Does trading? What does trading look like? Business.
So up to here, if you have any doubts related to this, you can ask like membership operators, logical operators, bitwise operators, arithmetic operators, comparison operators, binary operators. Still, one different kind of another operators are also there. I will discuss now.
Hey, Ravi, this bitwise operator, okay. Hello?
Yeah, please tell.
Yeah, so I have a doubt on it, okay. Since you converted all things on binary, I mean 0100 something, right?
Yeah.
Where you have written as like 2 cube plus 2 square and other
Hmm.
things, right?
Hmm.
Logically, if I do the mathematical operation on cube and on square, like 2 cube and 2 square, right? It will be
Hmm.
like 2 into 3 times, right? That's 8. And 2 into 2 times, that's
Hmm.
4. So 8
Yeah.
plus 4 should be then 12. But we got it as 8. So
Where
what
eight?
was the logic behind it?
Exactly where you are telling. Please tell.
So here I mean, 2 cube
Please tell
somewhere
the
you have written,
numbers.
right? We have written as 8.
Hmm.
I mean, 2 cube, 2 cube, 2 square,
Hmm.
and then 2 power 1
Hmm.
and 2 power 1. Something we have given, right?
Hmm.
So when logically we do the mathematical operation, that's 2 cube, that's 8, right? And 2 square, that's 4. And when I
Yeah.
do the addition of it, it should come as a 12.
8 plus 4 is 12. Where it becomes as 2 square, I become as 1. Where it is there, I didn't take, no?
Somewhere we have written it. I was about
No,
to
no,
stop you
no.
there,
I did not take. Once you please go through, I think I done it's correct only.
yeah. Let me check that again, and I will see if I get
Yeah,
any
yeah. Please go
doubt.
through it and let me know if you have any
But,
doubt.
so rest everything is fine. I mean, other things are okay, but only this bitwise operator I got little bit of
Next
confusion.
one is assignment operators. In this assignment operators, this is a kind of thing where you can give where that is here. Yeah, a plus if you are taking equal to 3, these are called our assignment operators. So in these assignment operators, just you are trying to give a plus equal to 3. Whenever you are trying to give a equal to a plus 3, you will be getting as 11. So that is assignment operators are like this. A minus equal to 5. If you are trying to call A, you will get as 6. That is indicates as A minus 5. Even A star equal to A star equal to 3. If you are trying as A equal to A into 3. If you are trying to call it as A into 3, you will be getting as 9. So like that, whatever the arithmetic operators you have, everything you are getting in the form of a multiplication, subtraction, and division kind of operations like this. So these are all called as a assignment operators. So if you have any doubts regarding operators, please let me know. So in the tomorrow's class, I will start the different data type collections like list, tuple, sets, and dictionary, and the strings. And with respect to all the inbuilt functions of all the different data types. What all we discussed today, like integer, string, boolean, complex, and a string, these data types we'll call it as a primitive data types. So this completed. From tomorrow class, we'll discuss this data structures. If you are joining for full stack data science, so whatever the necessary things which are required for Python, so those I will tell, and I will move somewhat bit faster in the Python class because I will more concentrate on the remaining topics. So Python I will go more fast. Please practice along with me. If you need, I can tell separately too. Okay. In tomorrow's class we will discuss. Okay for today. See you all in tomorrow class. Bye.